All right, so welcome to one of the final sessions for Graph Connect. We're getting close to the end now, but we're going to talk about writing an AWS Lambda function that's going to connect to Neo4j, run a query, and retrieve that back, but we're going to write all of that in Java, our Lambda code. So a little bit of background on me. My name is Jennifer Reif. I'm a developer and advocate at Neo4j, have been for a little over 4 years now. And I like learning. I enjoy technology. And then I like sharing what I've learned in a variety of different ways, whether that's through blogging or videos or conference speaking or meetups or virtual events or so on. I kind of enjoy it all. I do have some other hobbies outside of work, but most of those boil down to the fact that I'm kind of a geek, if you can't tell from my May the 4th picture there on the side. So my contact information's there in the lower left-hand corner. It will be on the final slide as well. But sometimes our best questions come to us after an event's over and you can't figure out how to contact somebody. So if you're interested or need to reach out to me for a question, feel free to do that digitally. I'm more than happy to answer those anytime down the line. But feel free to catch me in the hallways here too. I'll be around here as well. So talk a little bit about the architecture first. We are going to work with Neo4j, shock, disbelief for us being at Graph Connect, right? But specifically the AuraDB Cloud database as a service. And I've got some Java version data loaded there, so versions of the Java programming language through the years. And some information on that. We'll just write a kind of simple query against that to retrieve some of the data from our function, but we're not really going to focus in solely on that. We're going to write our code in the Java programming language. That's kind of my background. That's the language I most prefer. And then we're going to write an AWS Lambda, which is their version of the function service. Pretty much every cloud provider has some flavor of that, but we're just going to focus in on AWS's for today. So a little bit of background on this project. Why did I pick this? Kind of how I ended up into this. Was I found that there were very, very few examples out there for AWS Lambdas written specifically for Java and an external database, specifically Neo4j. You had a lot of things written in JavaScript. You had some examples and blog posts around Python and so on, but you didn't have a whole lot in Java. You also, AWS, of course, is going to use their own products, their own AWS databases, and you didn't have a whole lot of examples for external databases. So what do you do when you need to connect to something like Neo4j? So my goal here was to utilize example code. There has to be, a way that we don't have to reinvent the wheel every time. And so I was able to find a couple of examples, pull from that, kind of aggregate them together and make them something useful. And then, of course, we could write something more elegant and cleaner from there. So I created this version 1 of the code. Now, the examples that I came across and started with initially were pre-AWS CDK. The CDK is the cloud development kit, which is relatively new. It kind of bundles in a lot of the infrastructure and deployment steps for you so that you have less you do manually, less scripts you have to write yourself. But I didn't have that starting out, and so I kind of took sample code that already had kind of these deployment scripts, but it was a lot more manual intervention for me. I had to run each step individually, I had to pass in different things and write a little bit more code. So now with the AWS CDK, I have a rendition now that's been updated. I still have the older code out there if you're interested in that, but now the newest, latest, greatest thing uses that CDK. And of course, there's always more to do, right? I noticed last week that there's an update to the CDK. So there's a version 2 and the APIs have changed, so I need to update some dependencies and all sorts of wonderful goodness. So that hopefully will be coming, but just not at this point in time. We're going to utilize what's available in the examples for today. So I started with a code mashup. And we'll look at the repositories for this. I know that's kind of an eyesore. But on the left-hand side, we have AWS's sample code for the pre-CDK connecting for AWS Lambda in Java. And it basically just does a handler that takes an input stream from a JSON file, a local JSON file, and then exports JSON to an output file, which are both included in their repository as well. That's pretty much what that code does. And then on the right-hand side here is Aura's, or AuraDB's example code. They have a variety of different languages that they offer you for an example to basically set up a connection to Neo4j, run a query, and retrieve it. And so I was able to take basically these two pieces of code, kind of mash them up, and make them something useful. hopefully. So the version 1 code then, and again, we'll look at this in the repository, it'll look much nicer, but it's taking that input JSON file, running that, and then using that as part of something, and then exporting that to JSON file as well. Okay, so let's gear over to demo. I have very, very few slides. We're going to do a lot of live coding. So I will switch over now to browser. And this is the example we're going to start with. So this is their CDK Java version of the code. And all we're going to do for now is we're going to download a zip file of that. And that's going to toss it in my downloads folder. And I'll walk through the code when I open that in my IDE. And then I'm just going to open IntelliJ and open the folder from there since it doesn't have a POM at the project level. Oh, look, it already opened it for me. Nice. OK, so let me bring this full screen. Is that visible OK? OK, great. All right, so in the README, it does outline what steps you need to do to run and everything. It gives you kind of the project structure and so on, but we'll walk through that manually. So the main bit is that we have two major folders here. We have an infrastructure folder, which is what the CDK is going to use in order to package, build, deploy our applications. And then we have the software folder, which is where we're actually going to define our function kind of projects, if you will. So starting in the infrastructure folder, there's not a whole lot here. There's a few things in the POM. We have just a few dependencies for like the API gateway and the Lambda. The core, I think, is one of the libraries that has changed with the new CDK. That API, where it's being put and organized is different. But not a whole lot of major stuff going on in here. If we go over to the app, there's really not much in here either. It's just running a synthesize on the application itself. But if we go to the stack, this is really where rubber meets the road here. So we have, inside our stack, we have each function. It's going to set up some packaging instructions. So for instance, we're going to create a jar file for each function here, and we're going to put it in this asset output folder. And what that's going to do is that's going to give us a place to take all of those assets and push them up to AWS. Same thing for function 2. It's going to be very, very similar, just for the other function, jar file. And then it's got some builder options. What it's going to do is create a Docker rendition of this to package, deploy, and so on. And so it kind of creates the general Docker structure that it wants to include. It's going to externalize our Maven folder so that it doesn't have to pull down dependencies every time. It's going to use our Maven folder to basically take those cached dependencies into account. Then we're going to set up the builds for each of our functions. So this is actually taking the Docker instance and it's pushing our function over into that. So you can see we've set up a Java runtime of 11. It's using the software folder in order to grab the function. It'll set up the handler, the memory size, and build it. Same thing for function 2. And then we also need to set up an API. So what this is going to do is it'll push our functions up, and then we can access them using basically a REST API, calling each one of the functions using an endpoint we're going to set up, or a route in this case. And so it's going to set up a route for each one of our functions and let us be able to access each function via that route. And then just set up the general HTTP API there. So that's our infrastructure. We will need that. It gets used. The CDK takes care of that for us. Now, function 1 and function 2 are actually the same. They're just copies of one another. So I'm only going to go through one of these. Very, very similar. You have several, Amazon Lambda dependencies going on in here. Again, all this code just plain copied from the example code. But if we look at actually the source and the application, this is where the details go. So it takes a request event, and it's going to return a response event. Of course, it's setting up our headers for us in JSON format. And then here is where the core of this is. So it's going to grab some page contents. It calls the getPageContents method, which I'll show in just a second at the bottom. And it's going to pass in this URL. And when it gets down here, so it's going to pass in the URL. Basically, it's going to return the IP address for that URL. And it's going to output that with a message, hello world, and the location of those page contents, so the IP address. And it's going to return either successful, or if there's an exception somehow, it'll retrieve that and give that back to us as well. So that's really all the code is doing. And again, function 1, function 2, exactly the same. So with that in mind, we're going to jump over to our shell here, our terminal, and CDK, and we need to go to the infrastructure folder in order to build this. But I'm just going to build it as is for a second, just to show how this works, what we're expecting on the output side of things. Again, this is just the vanilla example that we were given by AWS. And this is going to take a couple of minutes. It does look like it's starting now. It'll build each of those functions, package them up, and get everything synthesized and ready for us to actually deploy. And then we'll come back and we'll run a CDK deploy, and that'll push all of our resources up to AWS. So while that is running, should only take, well, it might only take a second. We can give it a second or two. The deploy is what takes usually a little bit longer, and we only have 2 functions at this point. What we're going to end up doing is adding a new function to this to connect to Neo4j. So now we're going to deploy just these 2 functions for now, and it'll go through kind of its normal steps. I usually wait until I get, there we go, 1 response, so I know it actually is running. And then we'll hop back over to our browser here. And this was the original Java basic example that I pulled. I can zoom this in just a little bit. And we can kind of see we've got some shell scripts. It's going to create an AWS bucket. The old version did. Then we have our 2 step, which is going to actually deploy the resources up. 3 is how you can invoke the function from the command line. And then 4 is your cleanup. It's going to destroy the resources, tear everything down. But again, those scripts are very manual. You have to go in, you have to run each step, etc. And then the actual handler code, I use the handler stream of this. And so, yeah, it's going to implement the request stream handler. It's going to take input stream, output, and output stream. And it's going to log a couple of things, the event or so on. And it's going to basically write that event, take the input event, and write that event back out. And of course, I tweaked it for Neo4j. I took an input parameter, used that in the query, and then output the results to the JSON file. So still taking that JSON input output, but I tweaked it where the results from input and output were different, where this is not. But this is the original code. That's available and out there. I also have a blog post on the old code. So if you're interested in that, it's a complete walkthrough of everything I had to go through, how I set up not necessarily the AWS account, but some of the infrastructure things to kind of set it up correctly so that everything would run. And so that's available on Medium too, and that's findable. All right, let's jump back to our terminal and see, fantastic, it's done. So now we can curl each one of our endpoints here, and I can grab our nested endpoint for each function, so /1, and it should retrieve our hello world message and the IP address for that function. And then same thing we can do for 2. And we should basically get the same thing. Of course, we don't get the exact same IP address because your resources are going to be spread and dispersed. So, okay, this is working great. We know out-of-the-box vanilla code is working. Let's go back and add a 3rd function to this for our Neo4j stuff. So I'm going to take the function 2, and I'm basically just going to copy and paste programmers' favorite commands, right? Copy, paste. And so now I've created my function 3. There it is. We need to go a few more steps, though. First off, we need to create the information inside the stack so that it actually gets deployed and packaged up correctly, right? So we're going to start first here. More copy pasting, fun, except we just need to change this to our function 3. And 3. Maybe I should come back and somehow create like a, where you can just provide it a variable or something, and then it'll build each number of functions you have. There's an automation idea. Okay, so function, and that, and yeah, there's one more place that is here. 3, okay, and then the last thing is we got to add a new route. So this is going to add something new to our API, so we have something else to find this function. Okay, And that should put us in a good spot for that. So IntelliJ gets a little funky about sub-projects and nested projects. So what I'm going to do is I'm just going to open the function 3 project in a separate window, and we'll do all of our coding there for that. So again, POM's going to be exactly the same, except, yay, more copy pasting. So I'm just going to look for examples of 2, change that to 3. Yep, final spot. Okay, and reload Maven. Close out that lovely little message. Okay, and now we can go over to our app itself. The first thing we want to do is we want to be able to serialize and deserialize some JSON. And so in order to do that, I like to use JSON. And so it'll say, hey, I don't recognize this. Okay, fine, insert that, but add Maven dependency. There we go. Okay, so we're going to add the Google JSON library to our dependency. That'll add it to the POM for us. And so then it should recognize, except I just need to import the class to this particular class. Okay, and so then we need a new JSON builder. And well, of course it doesn't recognize that, so I got to import that and set prettyprinting.create. Perfect. Okay, so that's going to set up my object JSON so that I can serialize and deserialize some JSON. Next, I want to set up my connection details to Neo4j. Now, there's a couple of different ways you can do that. You can absolutely hard code them in your application, but who wants to do that, right? Probably not the greatest idea. What I ended up doing is creating environment variables inside the function on the Lambda UI, and then I can just use system.getEnv here and pass in just the names of those variables, and it will pull from the environment in Lambda and access those. System.getEnv and Neo4j user. And then one for password. And system, getEnv, Neo4j, password. Okay. One last thing I like to do is I like to output these. Now, of course, you don't want to output hard-coded values to your logs. This is going to go to CloudWatch, but I've had a few problems before where I mistype something or I don't set up my variables correctly, and then that totally kills the demo. And so what I like to do is just print those out just to make sure everything's good and it's all connected, and then we can go from there. Now, I need to create a driver instance so that I can connect to Neo4j using the Neo4j Java driver. Normally, when I just start typing driver, it wants to go to SQL for some strange reason. Why? I don't know. But we are just going to dive in and add our dependency here for Neo4j. And we're going to make it much, much better. Neo4j Java driver, and it pulls in. We're going to use the latest version, because why not? And update that. OK, now we should be able to go back to our app and pull the Neo4j driver there. And we're going to set up graph database dot driver, pass the URI. And then we need to set some auth tokens, dot basic, pass the username basically, and password, and then send in some config, which in this case is just default config for this point. Okay, so we've got our driver instance set up. That should help us connect to Neo4j. We still haven't done anything with it though, so let's fix that. The next thing we might want to add is our read query in order to connect to Neo4j. So we need to make this a string, because we have these lovely multi-line strings now in Java. We can set up our query. So we have a Java version, and we'll create a new line here, just for formatting's sake, where the j.version equals maybe something we would want to pass in. So we could make this dynamic based on a variable we could pass in, or a URL parameter in this case. And then we're going to return j.version as, I'm going to minimize that, as version. We can pull status as the status, so whether it's end of life or whether it's an LTS version or so on. We also have GA date, and we're just going to call this GA, and j.eol date as EOL. Okay, now I also am going to output this just for any sake, because I had a typo in my query earlier and it it came back with nothing. That's disappointing. So next, we probably want to pass it some values, right? We want to pass in the parameter that for version. So here we're going to say params, and we're going to have collections.singleton map. We're going to look for the parameter version, and we're going to use version to pass that in. Now, of course, I haven't created a variable for version, so let me fix that, and we're just going to initialize it to null for now. Not super great, but that's where we'll start. And then we have an if statement, so I'm going to pass this in as a query parameter, and I want to check to make sure that it's actually there before I set something that then causes problems later down the road, right? So we're going to test our input. I'm going to grab the query string parameters from that input, and we're going to get the object for version that's hopefully on our input, and we're going to check to see if it's not equal to null. If so, if it's not equal to null, then there's a value, and we're going to set version equal to the input dot get query string parameters dot get version, and then just to be on the safe side, I'm also going to output that. Okay. One other thing I do like to do just for sanity is I want to output my input object, and I'm going to do a json.toJSON, pass in the input. So we can see exactly what's coming in the request, make sure that our version is there as a query string parameter, and so on. So again, doing a lot of extra logging we probably wouldn't or shouldn't do, but just for sanity's sake. All right, now we actually haven't done anything with Neo4j, so let's do that. Let's start with our session. We need to create a session from our driver, so driver.session, and then with that, we are going to set up a record, of course. Okay, thank you, IntelliJ, for saying you need a semicolon with Java. And then let's take our session.read transaction. We're going to take a transaction. We're going to create a Lambda, doing fancy stuff here. Result, and we're going to grab, let's see, we need to do our tx.run, pass in the read query and the parameters. So we're going to pass in our query, we're going to run that transaction against Neo4j, pass in the parameter to help with that read query, and then we need to return something. So we're going to return the result, not response, result dot single. We're going to expect a single response coming back because when we query a Java version, we only expect there to be one. The only thing really left is we want to output that to make sure that that it's working, right? So we're going to output our result, and we're going to send json.toJSON, and we're going to output our record.asMap. So we're going to create a nice formatted map for that. Now, it's expecting input-output initially. Because we're not dealing with that any longer, I'm just going to output or catch Neo4j exceptions, because that way if something goes wrong with that Neo4j query and we get an error back from Neo4j, I want to be able to see that. And we actually are not using this page contents, so we can clean that out. Okay, now assuming I have not forgotten any important things, we should be in good shape to synthesize this. Go back to our CDK synth. And then after that finishes up, then we'll deploy. Now we have 3 functions, so it's going to build each one of those and package them up. So that's what the synth is going to do, and then then we'll come back and deploy. So that'll take a couple of seconds. I'll jump over to here and show off the Neo4j Aura. So this was the code that I pulled from. If I look at my main Aura panel, I've got a few different databases out there, but this is the free instance actually that I'm connecting to. And you can see under the connect example, it's got sample code, and that's literally what I copied from. So it's got all kinds of languages too. If you're not a Java developer, you can pull from various examples there, and this is the instance that's there running. Again, free tier, anybody's welcome to open that. Okay, we should hopefully almost, I wonder if this is function 2 or 3. Can't tell. Cool, build success. Great, okay, so now we're ready to deploy. And again, hopefully I've done everything correctly. I will go in and show you guys the environment variables just so you can see them, and I may have to create them again depending on if this deploys a fully new function or if it just overwrites something I've got out there already. But let me pop back over here. So this is where we can see the functions once they get there. So I can go on out, refresh. Oh good, it does still show, no, it does not show function 3 because I redeployed 1 and 2. It, I guess, cleared out my 3 for me. So I'll have to wait until it finishes deploying to show my 3. But we can look at function 2. And we have this code window. If your function code is relatively small, you can go in, you can actually edit your code from here. You can also test, so you can send it test events and test and invoke your function from here, which is really nice. Monitoring has kind of been my go-to tab. So it'll pull in CloudWatch logs. It's not always the most recent. So I like to actually use this button to view logs in CloudWatch. Oh, that's much better. View logs in CloudWatch here. The configuration is where I'm actually going to add environment variables once we get to function 3. Then of course you have versions and aliases and so on, but those are really kind of the core things. All right, let me go back and check because sometimes, oh yes. So this is just checking to make sure I want to deploy IAM policy changes. It's not going to deploy anything crazy, so I'll go ahead and add those in, and it'll finish up deploying there. So. Should just take it another minute or two to actually push everything up. And then once it does, we'll go in and look at function 3. So it does look like I'll need to kind of set those environment variables again, which isn't that big of a deal. Just no retrieving my credentials, right? Okay, I'll copy that because I will need that. Okay, let's go back and see how it's doing. Oh, great, almost done. And it should output that API URL that we used last time. So it'll give us probably the same one there, since we're deploying the same stack, just redeploying it. And then we can use that, and we'll query it once I get the environment variable set. Yeah. Come on, the deployment step's always the longest one. It always takes the longest. We only have 3 functions. Glad I didn't put any monoliths in today. There we go. Okay. So yep, there's our API up. And let's go over to the browser here. And function 3 shows up now in the list. I can zoom that in just a little bit more. And if we go over to our configuration, you can see we have no variables. Fun. So I'm going to add some Neo4j URI, and I copy pasted that in, grabbed it from my Neo4j Aura console, and then user, and this is going to be just Neo4j, cleverly enough, Neo4j, and this is our password, and I just went with something super basic here. Okay. So we're going to save those. That looks good. Now we should be able to run our function. So we go back to our curl, and we can test. I'll just test 1 just to show that those are still running in the background. And then let's go ahead and test 3. So what I actually need to do is all the way back. And it highlights. I think I have a key default set up incorrectly. But since we're going to add a parameter on the end, Z shell is kind of particular about me doing that. And so I have to encompass the URL in quotes. So we have our endpoint of 3. We're going to pass it that parameter of 17. And again, end quote. And hopefully, cross fingers if everything has worked, it will run our AWS Lambda, pass that version 17 to it, into our read query, which is going to run and hit Neo4j, retrieve the results back, and we get the results of our query. As you can see, we get those back in our result. We get the Java version 17. We've got the status of LTS. We have the day, year, month that it went GA, and when it's going to go EOL as well. And we could pass in something fun. We could go to version 15, and it'll go out and query 15 and bring those results back. So this one's already end of life. It went GA back in 2020 and went EOL beginning of 2021. And so we could, again, go through all 18 versions of Java, but we won't do that today. So let's head back over to Keynote and wrap up with a couple of resources. So the code repository for this is available at that first link. Again, if you go to the branch v1, that's the old pre-CDK rendition of the code if you're interested in that. Otherwise, just stick on the main branch with the CDK stuff. AuraDB, if you want to basically replicate exactly what I did today, you can create a free instance of Aura. All it takes, just fill out the form. And I've got examples of how to create the same data set. I have a script that you can use to just load in. The AWS documentation, that's the CDK and Java. There is examples of other stuff out there too. All of that should be linked in my V1 code, but that's working with the CDK and Java from the AWS documentation. The walkthrough, which is where I got the AWS code sample initially, is in that fourth link there. So if you're interested in the original stuff, that's available. And then I write a lot of stuff around Java, Neo4j, and so on. So like something like this blog post, and keep an eye out. I hope to update a new blog post with what we covered today as well. So if you're interested in keeping up with that, feel free to check out my blog too. Again, if you have any questions, I'll be wandering around. I'll be at the conference the rest of the day. Otherwise, feel free to ping me online. Thank you all so much.